Hi class, it's just me, Mr. Wee. So the part one kind of cut out in the middle of class, so I'm going to re-record where we left off. So I think we had an example, and we were finding the measures in intersecting circles. So intersecting just means circles that are intersecting each other, or yeah. And I think we had. So let me draw a more accurate drawing. So I think this was S, and then we drew a big diameter. Okay, so of a big circle. Okay, sorry, it's not the best circle. Still not getting great at this. Let's say that this is D, this is C, this is R, and then let's make a circle around this guy here. Okay, so again, very ugly circle. I'm so sorry about that. And the diameter we said was given to you of circle S is 30. The diameter of circle R is 20. So that looks more accurate too than my last picture. And then ds is equal to 9. So ds right here, from here to here, is 9. Okay. And you're supposed to find CD and find RC. So let's split this off sort of like in two columns. You don't have to do this for the homework, like in the format I'm doing, but you still have to have the answers. You have to come across the answers in a similar fashion. So CD, if you look at it, CD is associated right here. Well, CD and DS are related in that they kind of make up the radius of this giant circle. And why is that important? Because this giant circle, we know the diameter of circle S is 30. So that means CS, since it's a radius, we know it's a radius, is 1/2 the diameter. So again, you wouldn't have to write this in the actual homework, but what you would actually probably should write is CS is equals 1/2 times 30, which is equal to 15. And then you know that CS is also equal to CD plus DS, CD plus DS together, CD plus DS, and then you know that, so let's substitute. CS is 15, CD is unknown, we don't know that, so we'll treat CD as all one big giant variable, then DS is 9. So let's put in 9, and then simply put, you subtract 9 from both sides to get CD by itself, you get 6 is equal to CD. Boom. And then for RC, you do something sort of similar, because RC belongs to this guy here, and we just found DCD is going to be 6, so we'll say that's 6. And we know that since CRD, let's look at the whole thing. If you can just look at this circle here, if I can uncover it with my pen, this circle here is circle R, and its diameter is 20, the diameter, but we know that RD, if you look at it, RD is the radius of this circle, this really ugly circle. RD is 1/2 of the diameter of its diameter, and its diameter is RD is equal to 1/2 times 20, which is equal to 10. So RD is equal to 10. Then we know that RD is also comprised of two different segments, RC and CD. RD is equal to RC plus CD. We know that RD is 10. We just solved for that. RD is 10. RC we don't know. And then finally, CD, we just solved previously, is 6. Be careful, if you mess up your calculations for CD, you'll mess up your calculations for RC. So you subtract 6 from both sides, and you get 6, or 4 is equal to RC. There you go. That's your solution for that. And let's move on to where we left off at in the video as well. So we didn't get to this part in the video. This is the part of the video that got cut out. Let's go circumference. If we go back to the idea of a circumference of a circle, you probably memorize this as being, you just take 2 pi r, okay, or the diameter times pi. So what does that mean? Well, first off, what is a circumference? If you think about it, a square, when you take the area of a square rectangle, it's like length times width. You're talking about this. The area, the surface in between the boundaries of the square. If you think, so that's the area of a rectangle, actually. Let's say this is the area of a rectangle. Visually speaking, I'm not talking about the math. I'm just looking at the visuals. Then what is think about it this way. What if we just cared about this? Like we thought about a rectangle, but think of it as like around a house. Like this block inside here, like with a roof and like a door, and this is the fence around it. We only care about the amount of material, not necessarily to cover the whole ground, but the amount of material just to cover the boundaries, to make your enough fencing around the house. Well, it's called a perimeter. And that's a entirely different calculation, right? You have to, so if you remember, this is like length times width. So for area of a rectangle, that's length times width, right? And then for perimeter, you just add all four lengths, right? So you just put length plus length plus length plus length to get the perimeter. And by the way, just as trivia, when you have like squad policemen, they say secure the perimeter, or like even military men or military women or military anybody, when they work, they say secure the perimeter. They means surround it. So just to kind of give you a visual, just imagine like a whole bunch of dots. These dots mean like soldiers. It's always better to surround the perimeter, to not let someone out of the perimeter. So they just go around the perimeter. They never say secure the area, because what that would mean is you have a bunch of people going into the area, right? So that's different. When they say secure the perimeter, they mean go around the perimeter and secure it. Make sure that there's no one from the inside trying to sneak out, right? But if you say secure the area, that means all these dots, these people, these soldiers or whoever, have to go inside the area now, deep inside. Okay, so we don't want that. We like securing the perimeter because we want the people to come out towards us, not us going in for the, like in for like danger or something. Okay, so anyways, that's area and that's perimeter, right? Circle is the same way. There is a equation for a circle area, right? This is the area of a circle. We know that to be pi r squared. We have to take the radius and square it and times pi, and somehow you actually get the magical area of the circle. What is the perimeter of the circle? Just the area on the outside of the circle. That's what we call the circumference, if you think about it. That would be, so what someone found out is that if you took the radius and you don't square it, but you actually times it by 2, which is the diameter, and you multiply it to the magical pi, you get the circumference. Another way of saying 2r is diameter. So that's where we get the equation for the circumference, okay? So now we're going to work with a problem like this. So this is actually going to be from your book. Let's take a look at your book then. You see how far we need to go. Well, I'm sorry, I'm just looking at some papers right now. Okay, so we have a few things that we need to touch. So here, it's pretty simple. Let's go to, I'm flipping past the book right now. I'm going to show you when I get to it what we're going to do. We're going to find the circumference on here. So we're going to find the circumference of this problem. So this is a problem. This is, I think, page 717. So you're going to find the circumference of the helipad described at the left. So let's look. This is the helipad. Okay, this is where helicopters are supposed to land, but in this case, they made a tennis court on top of here, which is extremely dangerous. But let's check it out. In 2005, Roger Federer and Andre Agassi, which were the top 2 men's tennis players at the time, play tennis on the helipad. Incredibly dangerous. If you can see, there's no fence around there. And they want to find this. I think, they want to find the helipad. They want to find the circumference of this guy right here, the actual circumference that they can play in safely. Well, all they're given is the diameter, which is 79 feet, and the height, which is 700 feet high. So if we wanted to show the work, the diameter was 79 feet, and the height was 700 feet, but we're looking for the circumference. If you remember, circumference is equal to 2 pi r, or d times pi. Nowhere in here does it say that we need anything to do with height. So this is actually what we call a red herring. It's just additional information you don't need. In the same way that if you're only looking for the math here, you don't really care about the fact it's Roger Federer and Andre Agassi playing tennis on a top of a hotel. You don't need any of that stuff. You just need the math. But in real life, you might want to know why you're doing these things. So in this case, it might be for their safety. But I'm just saying for the math, you don't put in Andre Agassi or the hotel or anything in the circumference. You just go with the diameter and pi. In this case, it'd be 79 pi, and then you just say feet. You can just leave your answer like that, okay? So anyways, that's how you quickly calculate the circumference. Let's go to the next point here. Okay, so let's give you a tougher problem now. So this is still 11-1. So this is the circumference of a circumscribed polygon. So what this means is let's give you an example, a quick example of what this looks like. You have a circle, and in there you have a diameter, nothing new, but let's circumscribe a square. This isn't going to look like a square because I didn't draw my circle right, but this is a square. Boom, 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 and boom. If you know anything about squares, these should all be 90 degrees. So that's a circumscribed polygon. A polygon is a multi-shape, multi-length shape. So in this case, 1, 2, 3, 4. This is a polygon, and specifically speaking, this polygon is a rectangle. So let's say a square of length 9 inches. So each of these sides is 9 inches. In the square, at least, is 9 inches. And it's inscribed in circle J. Boom. Now we got to find the circumference of the circle J. Find the circumference of circle J. So what is that going to look like? So this is really tricky because I don't know what to do. I'm only given the lengths of the sides of the square. But if you're very, very, resourceful, you would realize that if you look at it, that is a right triangle right here. There are two right triangles. There's this one on the bottom, and then there's this one at the top. So if I separate that out, it'll look like this. Let's take the bottom one out. It looks like I have this right angle, the side length 9 and 9, and then I have the dash, and that happens to be the diameter. I don't know what the diameter is. Because the reason why I want the diameter is because I remember circumference has to be d times pi, or 2 pi r. And if I figure out what the diameter is, I can easily just calculate what the circumference is of the circle. Well, it's pretty simple. If this is a right triangle, I can use the Pythagorean theorem to solve for this hypotenuse, which happens to be the dotted line right here, the diameter. And I can plug in the diameter in here. Okay, so you just find out the diameter here. I'll say that the side length is d. So I'll say it's 9 squared plus 9 squared, like a squared plus b squared equals c squared. So again, a squared plus b squared is equal to c squared. That's the equation for a Pythagorean theorem for the sides of a triangle. So it's 9 squared plus 9 squared is equal to d squared. And I get 81 plus 81 is equal to d squared. Then I say that's 162 is equal to d squared. And then to find d by itself, I have to take the square root of 162. And that would be d is equal to, now to simplify this, you have to find out any common factors in 162. And here's a cheap way of doing it. There's 81 and 81. I know that there are two 81s. 81 times 2 are factors. 2 can't go any further than the factor of 2 and 1, but 81 can to 9 and 9. And if you remember the rule here, if there are pairs of numbers that are similar underneath a square root sign, you pull out that pair. So now it's 9 root, and then whatever number is left under the square root sign is 9 root 2 equals d. So that's perfect. So we just found out that d is equal to 9 root 2. Okay. So there you are. That is 9 root 2. And then to figure out what the circumference is, the circumference, that is equal to 2, or I'm sorry, that is equal to d times pi, and then d is 9 root 2 times pi. There you are. That is the circumference. And then into part 3, I gave you another example. And I let the students do this in the class of this triangle here. So this is another right triangle. You just can't see that. But this side is 3. This side is 7. Can you find the circumference of this guy? Again, you know the circumference is 2 pi r or d times pi, right? So just find the diameter, which happens to be, this is a right triangle. So if I redrew this triangle out by itself, I know that this lower side is 3, this is 7, and then this is the diameter that I'm trying to find. So that's 7 squared plus, you're going to see this work again in the next video. 7 squared plus 3 squared equals d squared. 7 squared is 49. 3 squared is 9 is equal to d squared. That is 58 is equal to d squared. And then you take the square root of 58. And then the square root of 58 is equal to d. And then you try to find common factors, but the truth is you won't be able to get anything out of the square root sign. So that your answer will remain square root of 58. But remember, that's not the final answer. We're looking for the circumference, which is d times pi. So circumference is equal to square root of 58 times pi, and you can leave it at that. And that's it. Okay, all right, thank you for joining me. I'm going to create a part 4 now. I'm all over the place for filming, but just go on to part 3 now. Okay, thank you, bye.